today, the solar system is about 4.5 billion years old and is home to 8 known planets. 4 smaller rocky terrestrial planets on the inside and 4 large gas and ice giant planets further out. 6 out of these 8 planets are home to at least 1 moon, but the largest have dozens. Some so large and complex that they would be worlds in their own right were it not for their captivity around their giant host. In addition to the planets and moons of the solar system, there are dozens of small dwarf planets, millions of rocky asteroids, and trillions of icy chunks arranged into bands and belts around the Sun. The outer part of the solar system consists of 3 regions: the Kuiper Belt, the scattered disk, and significantly farther away, the hypothetical Oort cloud. 3 collections of volatile ice chunks which formed closer to the Sun before being scattered by gravitational disturbances. The Kuiper Belt begins just beyond the orbit of Neptune, and it extends to around 55 astronomical units. An astronomical unit is the distance at which Earth orbits the Sun, just under 150 million kilometres. In comparison, the scattered disk extends much further, to over 100 astronomical units away, and the hypothetical Oort cloud is thought to start at around 600 astronomical units, extending for over a light year into interstellar space. In reality, the full scale of the solar system is so enormous that even light, the fastest thing in the universe, takes more than 18 months to escape the outer edge. However, the vast majority of the system's interesting features, including the most peculiar feature, life, are concentrated inside an area within about 50 astronomical units of the Sun, an area protected from harmful interstellar and intergalactic radiation by the Sun's heliosphere. The solar system today lies in a peaceful balance, with each of its 8 planets bound in predictable near-circular orbits. The small rocky planets sit neatly on the inside, with the larger gas giants further out. And so for a long time, we thought that this was the natural arrangement of most planetary systems. However, since 1995, we have been able to peer into the planetary neighbourhoods of other stars, and what we've realised is that systems of planets are very rarely this well structured and settled. Planets of all sizes and types can be scattered throughout their respected systems, and they don't necessarily stay in circular orbits. In fact, it is a fundamental property of planetary systems to be dynamic, which can profoundly alter the system's destiny. And it appears that we are no exception to this. Despite the neat arrangements of the planets today, it's likely that the solar system once looked like a very different place. Sadly, we as humans woke up far too late to witness the dynamic young solar system firsthand, but we are able to see the effects of certain key events that occurred early in its life, which allows us to start to put together a timeline. And thanks to telescopes like Hubble and Kepler, we've surveyed, catalogued and deduced the characteristics of thousands of other star systems at every stage of their life cycle, from their gaseous births to their violent deaths. This observed life cycle has helped us to connect the dots on a number of key questions regarding the formation of the solar system. The culmination of these decades of research is presented in the Nebula Hypothesis, our model for describing and explaining the birth of the solar system and all other star systems, and it is generally agreed upon by most scientists.
إذا زلزلت الأرض زلزالها وأخرجت الأرض أثقالها وقال الإنسان ما لها يومئذ تحدث أخبارها